Welcome to Brain Vision.
This is chapter 27, problem number 70. We have a bar that has length L embedded in a uniform magnetic field that is into the page. This point is A, the other point is B. So we're assuming that the bar is rotating around an axis that is perpendicular to the bar, the orientation of the bar itself. So then what we're asked to calculate is actually the infinitesimal torque about this point A. So we're going to do some differential work. We're asked to calculate dt in part A. So let's just set up the problem. Let's pick an infinitesimal dx here. From the pivot point to this dx, the distance would be x. This is x. And then, well, let's write the infinitesimal force that would be applied. If this is the direction of the current I, the force applied on dx would look like this from the right-hand rule. So then our df would be equal to I times b times dx, right? So then when we're writing the torque would be x times this df. Remember, the torque is r cross f, so that's where it comes from. In our case, we have the x. df then is our differential torque. So then x I b dx would be the final answer as far as part A is concerned. Now in part B, they want us to take the integral in order to get to the torque. So what we do, we take integral of both sides. So our x is from 0 to L because the total length of the wire is given to us as L. So 0 to L, x, I, b, dx. Now, I and b are independent of x. 0 to L, x dx. As you know, the integral of x dx is going to be x squared over 2 from 0 to L. Now, when we apply the boundaries, well, I, b, L squared over 2 minus 0, right, would give us the torque. And this torque is actually counterclockwise, right, from the right-hand rule again. Now, in part C, we're asked if all the magnetic forces applied at the midpoint of the bar, if this answer is consistent with that. So what does that mean? It means that this is point A, this is point B. The bar is extended between these 2 points, and this is the pivot point. Now, let's assume that we have the force that is applied at the center, midway between the two. So this distance would be L over 2. This distance also would be L over 2, right? So then let's calculate the torque. So then the torque would be simply the R or X, let's call this, but this time it's L over 2, right? X times F times the sine of the angle between two vectors. This is the X vector. This is the F vector. So then sine of theta would be 90 degrees here. Our X is L over 2. Our force is ILB, right? From the magnetic force, ILB, and we have sine 90, which is 1. So then when you look at the answer, it's actually consistent with the answer in part A. It's the same. I b L squared over 2 is the torque, same as part B.